Howdy folks. What we're going to talk about today is called the t-distribution. It actually, if you looked it up on the internet, you might see something that says students, S-T-U-D-E-N-T'-S, students t-distribution. And the reason it's called students t-distribution was because the guy who kind of came up with the t-distribution, he didn't use his real name when he made his work public. He used a pseudonym, and the last name of the pseudonym that he used was student. And so this is called, often called students t-distribution. And so I'm going to show you why we have the t-distribution and how to use the t-distribution in this video. All I'm really going to show you how to do in this video is how to read a t-table. A t-table. See, you already know about the z-table, right? And the z-distribution. Okay, we call the z-distribution the normal distribution. Okay? Okay? It's the normal distribution. That's what we've been using up till now. And you have used the z-table. And you calculate a z-score, and you use the z-score to find a p-value, a proportion, a population proportion, or a probability, right? Now, one of the assumptions or one of the ideas behind the normal distribution curve is that when you gathered sample data, when you gathered information, you gathered a sample that's kind of large enough, a large or a larger sample, that you can have a good bit of confidence in the conclusions that you draw based on that larger sample. So typically, let's say the normal distribution, let's say that you took a sample of, let's say, I don't know, maybe 71 people or 71 dogs or 71 houses or something like that. Or maybe it was more like 63 or even 57 or 55, okay? But a sample of that size is generally considered to be a larger sample, and anything larger than this is going to be considered a larger sample. But this t-distribution, one of the reasons that it exists is because sometimes we find ourselves in situations where we don't have the parameters or the statistics that we would like to have to answer a question, and sometimes we don't have a very large sample size. Let's say that we're gathering data and we're only able to get a sample size of, let's say, 21 people. Well, it's dangerous to draw a conclusion about a large population based on only 21 people. Let's say that we took 21 Americans and we wanted to draw a conclusion about all the people in America. Well, it's really sort of irresponsible or dangerous, or you should be cautious when drawing a conclusion about all Americans when you have only asked questions or gathered data on 21 of them. Now, you may be thinking to yourself, well, what's the big difference between 21 and 71? That's only 50 people. There's like 300 million people in America. Well, you would be pretty amazed to find that somewhere around 30 up to 60 is something magical takes place with data. Something magical takes place with the sample size that you draw. And so we usually consider a small sample to be a sample size that is less than or equal to 30, or maybe just less than 30. I'm sure lots of people, statistics people, can probably argue over what we should do with a sample size of 30. But generally speaking, you'll probably see somebody using the t-distribution if they have a sample size of 30. So a sample size of 30 is like this magical number. It's not a magical number in the sense that it's a hard and very clear rule. A lot of things in statistics are judgment calls by the people that use statistics. But in the class that you're in right now, chances are you want to go ahead and understand that anything under a sample size of 30 is considered to be a small sample, and anything larger than 30 can kind of generally be considered to be a larger sample. Okay? We tend to prefer, a lot of the things that we do, we tend to prefer to have a sample size that's upwards beyond 60 if we can. All right? So let me tell you about the t-distribution here. The t-distribution, my definition for it is that the t-distribution is a modified version of the normal distribution. It's a modified version of the normal distribution. So it's basically, it has most of the same qualities as the normal distribution. And that's one of the reasons why we use the t-distribution for a lot of the same things that we use the z-distribution for. Because the t-distribution is simply just a modified version of the normal distribution. But the t-distribution is more discriminating in the sense that it's more likely to tell you that the conclusion that you're drawing is wrong. And this is good, because when you don't have a very large sample size, you want to be told that you're wrong if you're wrong. Okay? There's more to it than that. Also, what if your conclusion is correct? What if whatever you're examining in research, whatever scientific thing you're doing, what if you have a hypothesis and you're drawing a conclusion between two variables or among multiple variables, and the hypothesis that you have is correct? Well, if it's correct, then even using the t-distribution, even using a stricter and a harsher analysis tool will still tell you that your conclusion is correct. And so the t-distribution is a great tool, especially when you're dealing with smaller sample sizes. All right, so we just have to talk about a couple different things, and then I can show you how to read the t-distribution. Okay? Okay, so here's what we're going to do. I want to compare the z-table that you already know how to use to a new tool that you're going to learn how to use, something I'm going to show you right now in a few minutes in the video. It's called a t-table. Let me show you what that looks like. This is a t-table. It looks probably not that much different than a z-table until you really start looking at it, okay? But I want to explain to you what the t-table, how the t-table compares to the z-table. In the z-table, okay, the top, across the top and down the side, those are the z-scores, right? You combine a number here with a number here, and you go from here to here, and you get a p-value. So the p-values are in the middle, and the z-scores, or the z-statistics, okay, are on the edges, correct? Okay, so all you have is z-scores and p-values in a z-table, okay? Now, in a t-table, it's a little bit different. In a t-table, you only have a select few p-values. The p-values are actually listed across the top. The p-values are up here, and then your critical values, the t-statistics, they're actually in the middle here. The t-statistics, or the critical t-values, they're in the middle here, okay? Now, across the bottom are some percentages, and the percentages across the bottom are the confidence, the percentages of confidence, assuming a two-tail test, okay? And then over on the left side, we have what are called degrees of freedom, DF. Now, degrees of freedom can, there are several things that degrees of freedom are used for in statistics. For now, I'm only going to show you what degrees of freedom are used for in the t-table, okay? But all you need to know for right now is that degrees of freedom is very simply calculated by n minus 1. Okay, that's the sample size minus 1. So if the sample size, if n is 27, then the degrees of freedom is 26. Very simple. Just reduce your sample size by 1 and you have your degrees of freedom. Okay? So what you do, here's how you use a t-table. I'm going to show you this in just a second, is first you identify your degrees of freedom, and they start at 1 over here, and they go 2, 3, 4, 5, 6, 7. They go all the way down to 30. Then they jump up from 30 to 60, and then I think 90 or 120 or something. Okay? So you find your degrees of freedom. Let's go to 26. Then you decide which p-value you are concerned with. And let's say the p-value you care about is 0.0500. All right? But really on the t-table it's only going to say 0.05. And then what you would do is you would go across here and down here, and this would give you your t-statistic. So whereas the z-score, you typically start with a z-score and find a p-value, with the t-table, typically what you do is you start with the degrees of freedom and a p-value, and then you find your t-statistic. Okay? So right now, let's go ahead and work out a couple situations on the computer. I'll show you the table, and I'll show you how to use the t-table. Okay, so here's what we're going to do. We're going to learn how to read this t-table right here. So in order to be able to use the t-table, we're going to need degrees of freedom. So you can see over on the left-hand side here, it says df, degrees of freedom. And then across the top, it says upper tail probability. That's one of the big differences between the z-table and the t-table, is the z-table gives us lower tail probabilities, where this t-table gives us upper tail probabilities. And that's fine. It's not that big of a deal. Now, notice along the bottom here, let me scroll down here, you can see that we have percentages. These are the confidence percentages, and that's if we're doing a confidence interval. And a confidence interval is always a two-tail cutoff, two scores that are cut off on the left and the right. Okay? And so in this particular circumstance, you can see our sample size, n, is 24, and we're being asked to identify the t-statistic for a 90% confidence interval. Now, for a 90% confidence interval, what we would do is we would turn that into 0.90, right? We'd divide by 100, and then we would subtract that from 1. Okay, so we would do 1 minus 0.9, which would give us 0.10, and then we would divide the 0.10, right? We would divide it by 2, and that would give us 0.5, it would give us 0.05 would be what we would use for the confidence interval, if you remember confidence intervals from the last class. So our p-value that we are concerned with is 0.05. So now if you come over here, if you go to the bottom of the t-table, whoops, I'm on the wrong one. If you go to the bottom of the t-table and go to 90%, you can see that right here. Now I'm going to scroll out, so there's 90%. We're going to go to the top of the column that says 90%, and you'll see that the p-value at the top of that column is 0.05, just like what we just calculated here. So that means that this column, this 0.05 column with the 90% at the bottom, that's the column that we care about right now. This column is what we care about. Now if we go back over here, it says that our sample size is 24, and our degrees of freedom is equal to n minus 1. And in this case, so that would be, our n is 24, so that's 24 minus 1. So our degrees of freedom in this case is 23. So our degrees of freedom for this problem is going to be 23. Okay? So degrees of freedom are 23. And if you look along the left here, you can see all the degrees of freedom here. We're going to go down. Do you see the 23 right here? We're going to go to that one. That's our degrees of freedom, 23. So now our degrees of freedom are 23. And now we want to go over to the column that has the 0.05 at the top. So if we come down 0.05 and go over 23, you can see that this is our critical t value right here, 1.714. And so we would say t is equal to 1.714. And that's how you use a t-table. All you need to know is the sample size to get the degrees of freedom. You get your confidence percentage, which will also give you your p-value. Remember, the confidence percentage is at the bottom, and the p-value is at the top. And then you just line up your column with your degrees of freedom on the left, and then that will give you in the middle, it'll give you in the middle your t statistic that you want for your problem. And there it is. Okay? All right, now I'm going to show you what to do with the t statistic. Okay, what I want you to do now is take your t-table, and you either got this t-table from me or you were able to download the t-table off the internet. You could go to my website, professorryan.weebly.com, and on that website you'll see, if you go to Statistics and go to day 12, you'll see that one of the documents, one of the PDFs there, is a t distribution. Okay, it says t distribution critical values. You can Google that and probably find a t-table somewhere. Okay, but you need a t-table to do what we're about to do. Here's what I want you to do. Let's say that we have a sample size of 17, and we're trying to do create a confidence interval where we want a 95% level of confidence. I want you to find the t statistic. Okay, so what we're going to do is, you can pause the video and try it if you want, but I'm going to do it right now, and then we'll do a few more. I'm going to go to where the 95% is at the bottom, 95% at the bottom, and if I go to the top, it tells me that the p-value is 0.025. And that's because we can take the 95%, turn it into a decimal, then subtract it from 1, giving us 0.05, then divide it by 2, and that gives us 0.025. And you should already know how to do that. That's from doing a middle percentage, and then also from when we learned how to do confidence intervals with the z distribution. Okay, so if you were to take this and do that whole process to it, it will ultimately give you a p-value of 0.025. So now what we need is, we need degrees of freedom. Well, what's the degrees of freedom if the sample size is 17? Degrees of freedom is 1 less. 17 minus 1 is 16. And now, to get the t statistic, all we have to do is go to the p column of 0.025 and then go down to degrees of freedom of 16. 0.025, degrees of freedom 16 gives me 2.120. 2.120. There's our t statistic. Let's do another one. Okay, so here we've got a sample size of 8 and we want to do a confidence interval with 70% confidence. Why don't you pause the video and try it on your own? All right, so our degrees of freedom here, if our sample size is 8, our degrees of freedom is 7. And then we're going to go to the 70% column, which is the third one over, and we can see that the p-value is 0.15. And if in that column with degrees of freedom of 7, we have 1.119. 1.119. That is our t statistic. Let's do another one. Okay, in this case, we've got a sample size of 26 and we want 98% confidence. Why don't you pause the video and try this with the t-table. All right, so if we go to the 98% column, you can see that the p-value is 0.01. And so now let's go to 0.01 and we'll go to the, we need degrees of freedom. 26 minus 1 is 25. So degrees of freedom is 25. In the column that says 0.01, go down to 25, and I'm seeing 2.485. 2.485. And what you're going to see in what we're about to do, because we're about to do confidence intervals, is actually what you're going to do is you're going to do plus or minus the t statistic. Because we're going to calculate a margin of error, just like we did in the last class. Okay? Let's do just a couple more. All right, here we have a 99% confidence level with a sample size of 19. So the degrees of freedom is going to be what? 19 minus 1 is 18, right? And then we want to look up degrees of freedom of 18. If we go to the column that says 99% at the bottom, that's a p-value of 0.005. And if we go to that column with the degrees of freedom of 18, I'm seeing 2.878. Plus or minus 2.878 is going to be our t-statistic. Let's just do one more. All right, now we're going to do an 80% confidence level with a sample size of 23. So our degrees of freedom are going to be 22. Our 80% confidence, if we look at that column, 80%, and then go up to the top, that's a p-value of 0.10. So we go to that column, 0.10, and go to degrees of freedom 22, and I'm seeing 1.321, plus or minus 1.321. So hopefully that was enough practice for you in using the t-table. Now you should have no problem using the t-table, and now we can move on to understanding confidence intervals when dealing with a small sample. All right, folks, what we're going to do now is I'm going to show you how to create a confidence interval for a small sample. Now, the good news is that doing a confidence interval for a small sample is basically the same as doing the confidence interval that you just learned how to do the other day. It's the same basic idea. Same formula pretty much. I'm going to show you that in just a second. But the idea here is the only difference in doing a confidence interval for a small sample versus doing a confidence interval for a larger sample is that you're going to get a t-statistic. You're going to use the t-statistic instead of the z-score. Okay, so we are not going to use the z-table. We're going to use the t-table. Okay, that's the only real difference. Now, what you learned how to do the other day was you could identify a confidence interval using the formula x bar plus or minus z times s over the square root of n. And remember, s over the square root of n, standard deviation over the square root of the sample size, that is the calculation for the standard error. So really, what we have here is x bar plus or minus z times the standard error. So now, the only difference between doing a confidence interval with a larger sample and doing a confidence interval with a smaller sample is we're going to get rid of the z and we're going to put a t-score in there instead, a t-statistic. Okay? So we get a critical t-value, and we're still using the x-bar, and we're still using the standard deviation divided by the square root of the sample size. Okay? So that's the only difference. So given that, let's go ahead and answer this question. Actually, before we do that, let me put the formula again. I'll put the formula so you can write it down. I'll put it up over here. All right? So confidence interval would be x bar plus or minus t, a t-statistic, times s, standard deviation, over the square root of n. There we go. There's your formula for a confidence interval. And you don't have to use a cursive t if you don't want to. Just make sure that it looks like it's typically a lowercase t. Okay? All right, so there's your formula. So we have this question here. It says, some researcher or manager took a sample of 19 things. That's 19 things means that's the sample size. N equals 19. Okay? In fact, let me write that over here on the side. N equals 19. And found a mean of 62. Well, the sample mean is 62. That means x bar is 62 with a standard deviation of 7.3. That's not 73, it's 7.3. So now s is 7.3. Okay? And then it says, the question says, using the 95% level of confidence, determine the confidence interval for mu, for the population mean. And that's what we do with a confidence interval. We're trying to identify an interval where we are hoping or guessing that the population mean is somewhere in between those two numbers. Okay? And then also, please identify what is the margin of error. We're actually going to identify the margin of error first. I want to remind you that this portion of the formula is the margin of error. So the part that just says plus or minus t times s over the square root of n, that is the margin of error. So I was thinking maybe we could do that first. Let's first identify the margin of error, then we'll do the confidence interval. So in order to do that, we are going to need a t-table. and look up a 95% confidence level. Okay, so let's get a t-table. Where did I put my t-table down? I have it around here somewhere. Maybe this is it. There it is. Got my t-table. You're going to need one too. All right, so in order to find a t-statistic, we are going to need either the percentage confidence or the p-value, and we have the percentage confidence. We also need degrees of freedom. And in this case, the percentage is 95%, which is p equals. So we go to 95% on the bottom, go all the way to the top, and the p-value is 0.025. 0.025. So that's the column that we want. It's the 1, 2, 3, 4, 5. It's the sixth column over. Then we need degrees of freedom. Degrees of freedom is the sample size 19 minus 1. 19 minus 1 is 18. And so the degrees of freedom in this case are 18. So with the degrees of freedom and with the p-value, we can go into our t-table, go to 0.025 and go down to degrees of freedom, 18, and I'm seeing 2.101. So our t-statistic is 2.101. That's our t-statistic. And so now we can identify the margin of error. The margin of error is going to be plus or minus the t-statistic, 2.101, times the standard deviation over the square root of the sample size. Standard deviation is 7.3, so put 7.3 divided by the square root of the sample size, which is 19. 19. There we go. And so now we'll grab a calculator and we'll calculate this, okay? So I got a calculator. So we'll do 2.101 times, I'm going to put a parenthesis, then 7.3 divided by the square root of 19. All right, there we go. And I get 3.519. It's 3.518617, but because I only want to go to 3 decimal places right here, I'm going to use this 6, and that's telling me to make this 8 a 9. So it's 3.519. So it's going to be plus or minus 3.519. That is my margin of error. And now, in order to do the confidence interval, I'm going to do the sample mean plus or minus the margin of error. And the sample mean is 62. So it's going to be 62 plus or minus 3.519. So I'm going to do 62 minus 3.519. And that's going to give me 58.481. 58.481 is less than or equal to mu, the population mean, is less than or equal to, now we're going to do 62 plus 3.519, and I get 65.519. And so here is our confidence interval, and we're saying that in this particular, based on this sample with this mean and this standard deviation, we are thinking that the population mean is between 58.481 and 65.519 at the 95% level of confidence. Okay? Let's do a couple more examples, okay? All right, here's another situation. It says some researcher or manager took a sample of 5 things. That's not very many, right? So we're going to use, so it's kind of a small sample, right? So we're going to use the t-distribution, 5 things, and found a mean of 112 with a standard deviation of 11.8. So let's see here. Our sample size, n, is 5. Our mean, x bar, is 112, and our sample standard deviation is 11.8. Okay? All right. So now it says, oh, I didn't give a level of confidence. Using the, I don't know, let's go with the 99%. Using the 99% level of confidence, determine the confidence interval for mu. What is the margin of error? Okay, well, we're going to need the t-table. So we get the t-table. And if we go to the 99% at the bottom, right, 99%, and then go to the top, that says our p-value is 0.005. So our p-value is 0.005. So that's the column we're going to use. Now we need degrees of freedom so that we can find our t-statistic. And degrees of freedom, df, well, that's our sample size minus 1. And our sample size is 5. 5 minus 1 is 4. So degrees of freedom, 4. So if we go to the p column of 0.005 and go down to a degrees of freedom of 4, which isn't very far, we get a t-statistic of 4.604. T-statistic, 4.604. Okay? And so now we can identify the margin of error. The margin of error is plus or minus t times standard deviation over the square root of the sample size. So that's going to be plus or minus the t statistic, which is 4.604, times standard deviation, 11.8, divided by the square root of the sample size, which is 5. And now we're going to grab a calculator to calculate this. Grab a calculator and we'll go 4.604 times parenthesis 11.8 divided by the square root of 5. Square root of 5. Okay, and then we'll press enter and we get 24.296. That's rounded. The fourth digit is an 8, so it's going to round that 5 up to a 6. So our margin of error will be plus or minus 24.296. And that's our margin of error. Now, to find the confidence interval, we need to take the sample mean, which in this case is 112, and then we have to add the margin of error and also subtract the margin of error. So we'll do so it's going to be 112 plus or minus 24.296. So let's do 112 minus 24.296, and that gives us 87.704. 87.704 less than or equal to mu less than or equal to. Now we're going to do 112 plus 24.296 gives me 136.296. And this is our confidence interval. Okay? I think we should probably do one more example. All right, folks, here's our last example. And here's what we have. It says some researcher or manager took a sample of 48 things, that's our sample size, and found a mean of 87 with a standard deviation of 16.2. Using the 90% level of confidence, determine the confidence interval for mu. What is the margin of error? Now, there's actually something wrong with this problem. And I want you to look at it for just a second. And I want you to think about this idea of the t-statistic and the fact that we're dealing with small samples. And what did I say previously in this lesson about what makes up a small sample? Do you remember what I said about small samples? Small samples are samples that are less than or equal to 30. What is the sample size in this particular problem? Look over here. The sample size is 48. This is not a small sample. Well, it's not exactly a large sample, but it's a larger sample. So we're not actually going to use the t-statistic for this one. In fact, I want to change the problem because I want to make sure that we learn how to continue using the t-statistic. But I just wanted to give you a little trick question so that you understand something. In the problems that you're going to do in this class, when I give you a confidence interval, You have to decide whether you're going to use the Z table or the T table. I'm not going to tell you in advance whether you should use the Z table or the T table. You have to look at the sample size and determine whether you should be using the Z table or the T table. Okay? So this is just my little trick to try and teach you how you have to decide whether you're using the Z table or the T table. Okay, so I'm going to actually give you, because we're not really going to do this one, I'm going to give you one more example to do, but for this particular example that we're about to do, you are going to need your laptop computer, you're going to need Excel, because I am actually going to give you data that you're going to key into Excel. You're going to find the statistics, you're going to find the sample size, the standard deviation, and the mean, and then you're going to find the confidence interval. All right, folks, let's say that some researcher or manager took a sample, gathered some information, and this is what they came up with. They came up with 10 numbers. I shouldn't have given. You should have figured that out on your own. You got 1, 2, 3. We got 70, 73, 92, 67, 91, 85, 74, 83, 85, and 91. And given that data, we want to find a confidence interval of the actual population mean using the 90% level of confidence, and we also want to identify the margin of error. So here's what I need you to do. What you need you to do is you need to take these 10 numbers here. Can you see them all? Yeah. You need to take these 10 numbers, and then you need to enter all 10 of these numbers into Excel. Then you need to go to the data analysis. Then you need to identify the descriptive statistics. Because what we need in order to do this problem is we need the sample size, we need the sample mean, and we need the sample standard deviation. So why don't you pause the video right now, write down these numbers, go into Excel and find that information, and then we'll continue from there. All right, folks, I just went into Excel and I did the descriptive statistics. And what I came up with was a standard deviation of 2.957, a mean of 81.1, and a sample size of 10. Of course, we already knew that because we counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now what we're going to do is we are going to do identify our margin of error using the T statistic, because our sample size is smaller than 30, right? And using the 90% level of confidence, we're going to create a confidence interval, okay? So we need a T table. Now, in order to identify our T statistic, we're going to need our p-value. Okay, well, the 90% level of confidence, if you go to the bottom, 90% level of confidence is in the column where the p-value is 0.05. And if you didn't have the percentages across the bottom, you could easily find this p-value simply by taking 90%, dividing it by 100, giving you 0.9, subtract it from 1, which would give you 0.10, I guess, then divide that by 2, and that would give you 0.05. And you've been doing this for a long time. It's the same thing as doing a middle percentage z-score, okay? Or middle percentage p-value into a z-score. So our p-value is 0.05. We need our degrees of freedom. Degrees of freedom are the sample size, 10 minus 1. 10 minus 1 is 9. So we have degrees of freedom 9. P is 0.05. Let's go into our T table and we'll find the T statistic. The T statistic. Critical T value. 0.05, going down to degrees of freedom 9. I'm seeing 1.833. 1.833. So we've got our T statistic, and now we can use our formula to get our margin of error. Let's leave this alone for a minute. We'll just do the plus or minus T, which is 1.833, times standard deviation over the square root of n. Standard deviation is 2.957 divided by the square root of the sample size, which is the square root of 10. Okay? And so let's grab a calculator. Got to do that. And we'll do 1.833 make sure that's right. Did I get that right? Yep, 1.833 times the 2.957 divided by the square root of 10. And that gives me 1.714. So our margin of error is plus or minus 1.714. That's our margin of error. And so now, if we want our confidence interval, we're going to do the sample mean, which is 81.1. 81.1 plus or minus the margin of error, which is 1.714. And we can now find our confidence interval with a calculator. Do 81.1. We'll do the minus first. Minus 1.714 gives me 79.386 less than or equal to mu, less than or equal to, and now we'll do 81.1 plus 1.714, and that gives us 82.814. This is our confidence interval. And here's what we're saying is that roughly interpreted, this isn't quite precise, but one way of thinking about it is that there is a 90% probability, we are 90% confident that the interval that we have chosen includes the population mean, which we don't know, and is a constant value. Okay, so we're hoping that this interval contains the actual population mean. Okay, and so this is how you calculate a confidence interval and a margin of error using when you have a small sample. And note that it's the same thing that we did in the last class, except the only real difference is that instead of using a Z statistic from the Z table, we found a T statistic from the T table. And that's all I have for you today. If you have any questions, just let me know.